So what we do is that we build secure infrastructure for the crypto economy. And what that means more or less is that we build solutions for people to engage with distributed networks like for example Ethereum in a secure way without having the issues that we see today where people continuously lose money. Yeah. So let's start looking at the markets. Right? A lot of you might have seen this graph before, and a lot of you might also know, since we have tokens, right, that this one actually goes all the way probably and lands down into this plant, sadly. I think it was like 827 billion that we peaked at lately, but basically the point here is that it's a very volatile market, right? And there's many reasons for that. Liquidity is one, price discovery is another. But I think that one of the general reasons that the markets are so volatile, to kind of show this behavior, is the fact that right now the crypto markets are transaction-based. What I mean with that is that if you go to the markets today, you can buy an asset, and this really works for everything, right? It's for Bitcoin, Ether, or any kind of resistance token. And if you buy an asset, you can ride with it, it goes up or down, or you can sell it. Those are the choices that you have. So, why derivatives, right? 4 or 5 of you probably already know that a derivative is basically a deal, right? It's a way to delay a transaction. Let's take my favorite example here. So, if I was an ice cream manufacturer, for example, okay, now would be a great time to sell ice cream, right? But let's say like 3 months ago, I was an ice cream manufacturer, and I was looking at the price of milk. And I was a little bit worried because you could see that the price of milk was fluctuating. And I obviously, as an ice cream manufacturer, need a lot of milk to produce ice cream. So what I would do is to call up a guy with a bunch of cows, like a farmer, and ask him, hey, how about making a deal today? If we agree today that I can buy your milk in 3 months, then I'll give you this price. And the farmer and me might heckle a bit over that to reach a deal. And then we have a derivative contract, right? That would be a forward contract because we're delaying the deal 2 months into the future. So in this case, you can see that a little bit later, the transaction takes place and it's ice cream time, right? Because I, as an ice cream manufacturer, could access the milk on the market at the price that was good for me. Right? Obviously, there's many risks. This could be good for the farmer, it could be good for me, or it could be bad for the farmer or good for me, and good for the farmer or bad for me. Basically, what this kind of contract allows people to do is to allocate risk efficiently. Right? So you can use this, as we saw now here, to hedge an asset on the market, or you can use it to speculate. And as you can probably imagine, most of you might know, speculation is a bit more sexy than hedging, right? So a lot of people are using these contracts to speculate on the markets, hence the 2008 crash, like this, like that. But more or less, if we look at this in a rudimentary way, right, in a very naive way, we can say that all the stocks on all the exchanges in the world listed are worth something, or was worth something like $64 trillion in 2060, right? So the reason why I'm taking this number is that it's called market cap. And those of you who were familiar with the graph from the first slide, or the second slide, might be familiar with the word market cap, the market capitalization of all the assets on a market. So if we say that all the stocks in the world is worth 64 trillion, we can look at the value of all the derivatives in the world. And the gross market value, which is the value that is traded, which is the value that is traded in a derivative, is worth, or was worth, 20.7 trillion. So as you can see here, it's a pretty significant chunk of the global economy that is either somehow involved with or being traded in a derivative contract at all times. And right now, there's no solution for this on the crypto economy, or in the crypto economy, but we assume that there will be solutions and we will be one of them. And when this market emerges, when this concept of derivatives on crypto matures, there will be a market size similar or maybe bigger, maybe smaller, on the crypto markets for these kind of financial products. That's basically the finance part of this talk. So now let's get to the good stuff, right? Smart contracts. You probably all know what that is, right? I'll take that as a yes. Okay, smart contracts are great, but on Ethereum especially, and then also on other platforms, there are issues, right? For example, one of the issues is that it's difficult to code, right? I'm sure all of you probably would agree with that. Even though you might be good at it, it's pretty difficult. And this means that people make mistakes. And human errors is actually one of the highest risk factors on blockchain today. I think some of our colleagues from Singapore looked at the Ethereum blockchain with an analytical tool to scan all the existing smart contracts currently deployed. And they found that 45% of the smart contracts deployed actually had a list of known bugs or errors in them, right? So what does this mean? It means that people make mistakes all the time. And if people keep making mistakes, it's probably the tools that are wrong and not the people, right? So our mission basically with Firmo is to supply people with the tools, the infrastructure that they need to build or to execute deals on blockchains. Because we think that this is really the thing that prevents adoption from happening as a phenomenon, right? That people look at these markets and they look at the DAO hack or the parity wallet hack. You probably read about that in the news, right? And they say, wow, okay, 500 million out the window here, 300 million out the window there, right? How am I ever supposed to trust my money with that, right? And that's a fair argument. I think it makes sense, right? So we need a solution for that. Looking at Solidity as a language, we see, for example, here an example of an option contract that we wrote, that Dash wrote in Solidity. And as you can see, it's a fairly complex piece of code here. And this is because I think that Solidity as a language is Turing complete, right? And those of you who had a dip into computer science knows that Turing complete languages are very broad and they can express a lot of things. And this is really cool, right? That's a great thing, great asset to have. But it also means that there's a lot of complexity. And usually, complexity, as we saw before, follows security issues, right? So, this is why we built Firmolang. And Firmolang is our own little language. So, where we saw Solidity before, you see now the same contract here, or actually a slightly different contract, but that doesn't matter, in Firmolang. Firmolang is made, first of all, to be secure. And for those of you who know what security is in computer science, we formally verified the language to make sure that the properties of the language correspond to what you write with it. And as you can see here, those of you who can see it on the screen, it's fairly readable. It's seemingly intuitive. I like to think that it's fairly intuitive to write a contract with this language, which also means that you don't need to know how to code to write a contract with this language. And then the coolest part, as Troels also mentioned before, is that having our own language makes us blockchain agnostic, more or less. And what does that mean? That means that we can compile this language to any kind of blockchain. Right now we compile to EVM, which of course is why we're here today. But we can also compile to other blockchains, and we are working on compilers to Quantum, Cardano, and Neo as the first releases. So this is our cool new UI that I actually just received today and put in the presentation because I wanted to show you guys. We're going live, I think, fairly soonish. We're setting the date in around 2 weeks. with this product here. What you can see here is a list of contracts. And as you can see, the dates and the assets are represented by the figures and the numbers there. So this is how we imagine that people can engage with our product and create derivative contracts. Obviously, as you can see from the numbers, you don't really have to be rich to create a derivative contract. You can basically do it with this amount of funds. Yeah, and I think that's pretty exciting to look at, actually. Yeah. Okay, we already talked about that, actually. Okay, so the point, actually, maybe to expand on that a bit, the point with formal verification is that it is the concept most used for secure implementations in technology today. When you take a ride with the metro, or when you fly on the plane, or even when you use your phone to access a satellite, you're most likely communicating with formally verified software in one way or another. And the reason for that is that things that are extremely reliant on a process to be fully functional every single step of the way need formal verification as a method to provide the security to the end user, providing them with the knowledge that when they engage with this product, it works. And I think that's actually it. I think I popped that slide in a bit too early with the UI, but I wanted to show you guys a comparison here between contracts in Solidity and contracts in Firmo. Actually, perhaps we should go to the demo now, because then we can show real contract instead of me just going through it.
Sure.
Yeah.
Just a second. Just need to start something.
Yeah. Will you talk people through it, Dash?
Sorry?
Will you talk people through it?
Yeah, sure. And output is API and bytecode. That's how it works. You can see this is a symbol. To the demo now. So what I try to do here is I try to show you guys what you can build with this. So let's go to localhost 8080, and this is built on top of MetaMask. Need to log in a bit. So it's trying to change the network. So I'm running a Ganache server on local network for testing purposes. And here in this test network, I have created 2 users. The first one is called Alice. So let's check how much Ether Alice have, and how much EOS and Binance coin in this case we have. And Alice wants to create a future, so she goes to the marketplace and create a future, and she wants to sell, let's say 20 EOS, and wants to buy 80 Binance coins, and she wants to do it in, yeah, let's say 10 seconds, because we don't have that much time here. So let's go to Bob. Bob is the other guy. He goes to the market and he sees this product. Oh, buying 20 EOS and selling 80 Binance. I want that. And Bob accepts the future. Then he's going to wait 10 seconds. It's going to be executed on the blockchain. And now the maturity has been reached, and the contract can be executed. So we can see here, you can submit and go back and refresh a bit. It should be mined in 2 seconds. There you go. So we can see here, Bob has 120 EOS now, and he has sold his 80 Binance coins to Alice. So yeah, that's it.
Cool.
And if any of you developers want to play with this, please come to me afterwards, and yeah, we will figure something out.
Yeah, as mentioned, we're going live on testnet aiming at 2 weeks. Yeah. At which point you'll be able to play around with the product yourself. And also, if you're not a developer, I think you should talk to Dash. Get involved. Yeah. Yeah, that's basically it for us. Maybe you could take our Telegram logo up. So we have a Telegram, and we'd love to talk to everyone. So please grab a picture. If you're not on Telegram already, I would recommend you to download.
Do we have a QR code or something? But you can actually go to our webpage.
On our webpage, we also
Firmo.network, where we have technical paper and more, that goes more into the depth of the this presentation, and also we have the Telegram there, and Reddit and Facebook and YouTube, whatever you guys need. Yeah.